Hello, welcome to the Infix engine development vlog. So today I'm going to be talking about why I am rewriting the Infix engine. And the basic reason is my goals have switched from being just one specific idea in my head to trying to make something more general and usable for everybody. So my original idea was I knew I wanted to do something with fluid simulations, and I thought just doing something with the 3D texture would work very well. But as I have found out that it actually is very limiting because I can't extend the fluid or the volume as the water moves around. And so that one idea has kind of grown into, well, me stepping back and looking at what is the big idea of the Infix engine. The big idea, it's allowing users to create ideas, prototypes, and games with both low-level and high-level abstraction depending on the needs of the individual application. And so the way that's going to work is, instead of restricting people to just one type of data type, like the original engine was doing, it's going to allow people to use an Octree to store any type of data type they like in all of the leaf nodes of the tree. The very convenient thing about this is, let's say you have a data type that you've come up with and you really enjoy. The only problem is it only works very well in one specific use case. Everything else it's kind of not very good at. And so you could use that data type for that specific use case in the Octree. It's basically a way to fill an entire volume with all different kinds of data structures that would be really helpful to use. So you might have one data structure that's really good at animating something, and you want something to play as an animation, as a voxel model. And so you could use that data structure in this section of the Octree. Or let's say you want something, you just want to keep the raw volume data of a section of the volume. So you could do some other things with it, like it would be really great to do cellular automata in this small section with like a fire or something that's being animated with cellular automata, and an animated thing over here, and or you might really enjoy having a different data structure that is more aligned with one paper's description of their data structure or another one. One specific one is GVDB. You could implement that fairly easily, and you could get really well fluid simulations going just kind of right out of the box once you get all of the data types working. All you need to do to create your own custom data type is to supply all of the functions in the CPU code and the GPU code that would need the Infix engine to run on. And obviously, once you've supplied all of those functions, then that means you can use other functions that the Infix engine supplies to you to be able to use. And so that, I feel like, is a really good sweet spot with specifically voxel engines. Now, something that's really important is that there's different ways to think about voxels. In this case, voxels and rasterized graphics are basically two separate worlds, where this only focuses on the voxel world, mainly grid-aligned voxels. And so you might think that's really limiting, but when you start thinking about all of the capabilities of rasterized graphics and all the capability of voxel graphics, it's kind of strange that we haven't split them in two separate worlds yet, or at least started thinking about that in that kind of way. What I've mainly seen in a lot of papers and implementations online is voxel-assisted rasterization. So you might voxelize a world to provide global illumination for shading specific triangles. But in this case, it is all pure just volume, and all can be interpreted through these different data structures. Currently, I am writing up the class overviews of how I want to break everything up in the Infix engine and make sure that things are possible to do with computers, because it would be bad if they weren't possible. But as far as I can see, as of right now, everything's going and kind of just coming together. I'm going to be finishing up planning and writing down the classes and moving from OpenGL to Vulkan, because the Infix engine really needs a lower level API to work with all of this memory management that it's doing. Something like OpenGL is great. The only problem is you can't manage memory and buffers and textures and do things without a more modern API. Although everything that I'm describing as of right now is not set in stone permanently. Like, things are able to be changed and move around. The last point I want to make: anybody can add anything to the Infix engine, whether that be like they want to handle sound, or they want to handle their own custom, like really anything, because it's all open source. Going back to that different levels of abstraction, I'm kind of split between, should I have a virtually compiled language like C# or Lua or something like that, so that people can interact with the engine on a higher level, so they don't have to deal with some of these low level languages, and just kind of have things there and readily available to them, and then have people, if they want to really get into it, do the C++ and all of this lower level stuff. Voxels are, as an idea, they're always changing in my mind. And I'd really like to bring like voxels, instead of just having them as an add-on to a rasterization engine like Unity or Unreal, then they could just be a whole system in and of itself. Which there's a few things that I'd like to really keep the idea for in the Infix engine, which is, if you want to have your own custom shader, like for example, if you don't need shadows, then you can like just code so rays only hit once time, or you can make bounces, or you just want a fully path traced scene, or whatever shader outline you want to have. Obviously there will be like one given in the Infix engine that will just be enabled automatically, and so just something like that. And so you could have something like per voxel lighting, which is really interesting about global illumination, and since this is its own custom, you can make your own custom shader outline. You can also have non-Euclidean geometry and non-Euclidean data structures if you really want to go into it. So, which is pretty interesting. You could also do cellular autonoma, which would enable people to just like 3D conway of life or something like that. I've found a really interesting YouTube channel, I'll probably link it down in the description, called the Sand Pond Saga, which is specifically about voxel cellular autonoma using a spatial programming language, which I think is really awesome and could possibly be implemented very easily into the engine. And so loading infinitely both up and down, and what I mean by that is and out. So just like in Minecraft, how you would load voxels infinitely with Perl noise and then store that data and then send it to the hard drive to then be recalled later, you could do the exact same thing, except not only with outwards, but like with detail. So if you wanted to get really, really close to something infinitely, you could technically do that with Perl noise. It would be probably pretty complex and really pushing the limits of the engine, but it would be really cool to just zoom into something infinitely and then zoom out of something infinitely. I'm really going to focus on trying to make that possible by dynamically allocating the Octree, both so you can have variable resolution as you go in different levels of the volume, and a Perl noise interface. Really, this is the only way you could do that, because you wouldn't be able to store this all as raw data, because that would take more data than the computer could actually take up. And palette swapping, which is pretty interesting. That's about it for things that I have on my mind that I want to keep possible in the Infix engine. Just keeping a few things in my mind. I'll slowly add more things to this list of trying to make this engine as general as possible, but I think that's a really great outline for just starting up and planning things. I just want to mention, like, again, none of this is set in stone, and if you guys have any suggestions in the comments, I'll definitely listen to them, and any ideas about what you might want to like implement with this. The big idea is pretty much that I want the Infix engine available for anybody to use, and really create somewhat of a community of a few people that might want to work on it, either just casually or adding like one or two things. It would be really helpful and interesting to work with a lot of different people, but I don't know, maybe this will just stay really small and just kind of something I enjoy doing. I feel like voxels have just been like really interesting to me, and I know people always keep on saying that voxels are just around the corner and they're gonna come out big, and they're gonna replace triangles and rasterization graphics, and I don't know, I kind of feel like that it's not gonna be like what people expect it to be. Like, really, life just kind of throws curveballs at everybody, and when somebody promises some technology and they come out with this and everybody's like, oh, we're gonna switch to different graphics pipeline and stuff, that's probably not gonna change. But I'd kind of like to switch people's mentality to thinking that voxels will replace rasterization of graphics too. This is just a different category in the graphics world. Like, if you want to program with voxels, or if you want to program with rasterization graphics, then you have the option to do either. And that's what I really want to give people the ability to have. I don't really feel like that's completely there yet. Obviously, you have plugins that you could use with, like, there's like one specifically for Unreal Engine that I've seen, and I just don't feel like voxels have reached their fullest potential yet. Like, there's so many cool data structures out there that you could use to make some really cool effects, and I just want to give a really general model, just that can group many people's ideas together into one thing. And it may only be that I'm just trying to implement all of these other papers and ideas into the Infix engine for the next couple of years, but that's what I really enjoy about voxels, is they're not set in stone yet. They're new and cutting edge. They've kind of always been new and cutting edge. Like, we're always trying to figure out where do voxels fit into this niche of computer graphics. They're so interesting, but yet so restrictive in the same way. And so I think that's going to be it for this episode, and I hope to see you again in the next episode.